Hi SecurityTube. Welcome to part 6 of the wireless LAN security mega primer. In this video, we will look at pawning hidden SSIDs. So, all of us know what SSIDs are, which are service set identifiers or simple names with which we can identify our network, right? So, as an example, this access point has SSID Tsunami. Now, typically what happens is an access point, as we saw in previous videos, advertises its SSID in its beacon frames, right? We looked at the packet header, and if you remember, we located the SSID. Now, what is the problem here? Well, by doing this, the network is making itself very easily discoverable. And thus, apart from even a legitimate user who may be looking at that SSID and connecting to the network, even a hacker, an attacker, cracker, whatever you want to call him, can sit in the parking lot and actually get an idea that so and so SSID actually exists in the vicinity, and he can map, enumerate that network, even connect to it, and do a host of other things. So this is where the concept of hidden SSID came in. So what is hidden SSID? Well, the whole idea basically is to turn off SSID broadcasting in the beacon frames, right? So what now happens is the access point sends out its beacon frames, but the SSID field is all null in it. And basically, what this also means is if you're just monitoring beacon frames to find out networks around, you will not be able to figure out what the SSID is. Now, in my humble opinion, this is nothing but a security through obscurity technique, right? We are trying to obscure the SSID by hiding it and hoping that an attacker will not detect or discover the network. And hidden SSID is by no means any form of security at all. It is just a deterrent to novices who probably anyway might not be able to do much damage to your network. For the experienced wireless hacker, this is not even a challenge. Okay, so let's try and understand this concept of hidden SSIDs a little bit better by actually logging into an access point and looking at various things. So this is a D-Link access point. Let me quickly log into it. Let's go to the wireless settings. Manual would do just fine. And if you notice, we have a wireless network called SecurityTube running on channel 1, and visibility status, which is what actually determines whether this SSID is hidden or broadcasting, is set to visible, which means the SSID is currently being broadcasted in the beacon frame. Let's quickly verify this by going into our backtrack instance. And what we can quickly do is run arrow dump on the monitor mode interface. We actually know that our access point is on channel 1, so maybe we can just restrict ourselves to channel 1 for the time being. And if you notice, we are able to see our network SecurityTube on channel 1, and of course arrow dump was able to discover the ESSID, right? Okay, let's quit this. Also verify the same using Wireshark very quickly. Let's start a capture on the interface, mon0. We are able to see a lot of packets. Let's stop the capture and let's actually go ahead and select the SecurityTube network beacon frame. And as you can clearly imagine, we have the SSID parameter in the tag parameters, and it has been set to SecurityTube, right? Here it is. Okay, great. So now what we'll do is let's quickly just add a filter for this BSSID, which is the access point advertising SecurityTube as the SSID. Let's apply this as the filter. So now we are only able to see packets coming from the particular access point we have in our lab setup, right? Okay, now what we will do is let's turn off SSID broadcasting. So now let's go back to our D-Link access point and say, let's make the status invisible. So this is going to turn off SSID broadcasting. Let's save the settings, and I think now SSID broadcasting has been turned off. Let's verify the same by going into our backtrack instance. Let's quickly go full screen. Let's once again begin a capture, and what we are doing is we are letting this filter remain, right? Basically so that now we can look at the beacon frames from this BSSID. Right, let's begin the capture. Capture has started. Let's apply this rule, and if you notice now, if you kind of stop it, you will actually see SSID is equal to broadcast. Actually, broadcast is not really the SSID value. What it just means is the SSID parameter is not containing anything. If you look at the tag length is coming to be 0, which means this is a null SSID. And what it denotes to all the clients and everybody is that this access point does not broadcast its SSID anymore. So kind of zoom in there and let the fact sink in that length of the tag is 0, and hence the interpretation as well. It's kind of hidden, but the network is there, right? So this is how hidden SSIDs are implemented using the access point. Now let's go back to our slides. Now here is one interesting thing I want to just quickly show you. Here is a presentation which I had made unbelievably 8 years back in 2003 when I was interning in HSR Zurich. So Hochschule for Technik, there was this university where I had gotten an internship under Professor Beard Stettler, and I had worked on WLAN security. And this is that same presentation I was referring to for some graphics, etc. And for a minute I laughed because SSID broadcasting and the problems therein have been discussed since time immemorial. And till now, after 8 more long years, people still misunderstand SSID or hidden SSID to be a security feature. Unbelievable. Unbelievable. Anyway, well, good for us security folks, because that ensures we have employment. Nah, I'm just kidding. I'd be happier living in a safer world, probably making a little bit less money. That's okay. Okay, so let the games begin. Pawning hidden SSIDs. Multiple techniques can actually be used, and here is the kind of whole solution to the problem. Well, hidden SSID just tells you that there is no SSID being broadcasted in the beacon frame sent out by the access point. However, the probe packets, request responses, and association packets actually contain the SSID, and they really cannot be masked because those SSIDs are required for an actual legitimate connection to happen. So what is the solution to the problem? Well, first solution is a passive solution in which a hacker is silently waiting and monitoring the air for a particular BSSID. And the moment he actually sees a new client connect to that access point, then the probe request response and the association request response packet will go through, and these packets would actually contain the SSID which we will unearth. Right? So this is the first technique. Let's go through this technique first. So now let me actually go to arrow dump and let me start arrow dump. Right? So it's currently monitoring this channel. Let's actually minimize the exposure area further by actually telling arrow dump to just go ahead and, oh, it was not able to detect. Let me just quickly, okay, it has. This is on the one on the top is the one basically. Let me also add a BSSID filter, and this is actually the BSSID of our access point, the MAC address. You can verify that by even looking at the Wireshark file, if you remember. Right, this is the BSS of our lab access point. So we can come here, add this as part of the filter as well. This way what happens is we'll only be looking at packets for our access point. That's it. Not really bothered about everything in the air. Now if you notice, this time it's unable to actually figure out an ESSID. If you remember the last time when ESSID was broadcasting, it had written SecurityTube here, right? So now what we are going to do is we are going to connect a legitimate client, and this is the passive way of finding the ESSID. And we could also start a quick capture in the background. Let the capture happen. And I'm going to be using my iPhone to go ahead and connect to the access point. Right, this will just take a minute. So keep watching this little field here. The moment the access point and the Wi-Fi get connected, you would actually find that you would be able to figure out the ESSID. Can you see that? I've connected to the SecurityTube network, and the moment the client connected, immediately AeroDump was able to figure out the ESSID, right? So let's exit AeroDump for a second, go back to our Wireshark capture and just stop it here. And what we can do is, let's start looking at all frames apart from beacon frames, right? So that we get some idea. Okay, so now we actually go ahead and get a lot more packets. And what we are really interested in is looking at the client's probe request, probe response, and association packets. So here they are, our friendly little packets, right? So what we can do is we can now change the frame of reference to just the client and actually apply this as the filter, which is probably give us the probe request packets as well, right? Because probe request packets is just a general broadcast packet. So we can just apply this as the filter, and instead of destination address.da, let's just keep it ADDR, which means it can appear in any one of those address fields, right? Okay, perfect. So now if you notice, the Apple client, which is basically my iPhone, is actually making a lot of probe requests and getting probe responses, right? So if you look at one of these probe requests, it's making probe requests for multiple networks. Here is one it has made, and if you notice, the probe request packet actually contains the SSID of the network here. And this is the very first fundamental flaw, because whenever a legitimate client which has previously connected to that network is going to be in the vicinity, it's going to send out these probe request packets to the broadcast address, as we can clearly see here. And that probe request packet will contain the SSID. And hence, by monitoring these probe request packets, we are able to figure out what is the SSID of the hidden SSID or non-broadcasting network available in the vicinity. Now, there are other packets as well which contain the SSID. So we can quickly check that the probe response packet sent by the access point also contains the SSID, right? Similarly, you can actually check for which packets and which don't. One easy way would also be probably to go through the standard itself. But if you don't have the patience, well, here is where all of this comes to our help. If you notice, the authentication packets actually do not contain the SSID. But if you go to the association request packet and kind of open it up a little bit more and look at the various parameters, you will notice the association request packet contains the SSID, and the association response packet, if you kind of try moving and look at it a bit further, you would be able to figure out whether it contains that or not. So I leave this as a simple exercise to you to figure out if the association response contains the SSID or not, right? Leave behind the reply in the comment section and let's see who can get to it first. Okay. Okay, we are having fun. Let's come back to our presentation. So this was technique number 1, which was a very passive technique, right? The attacker did not do anything. He just calmly waited for his prey. The prey was a client which connected to the access point, and unfortunately, as all management control data frame packet headers are not encrypted in any way, and in plain text, we were able to figure out the SSID. Now, the second technique is an active technique, and this is where probably you patience is not a virtue for you, and you really don't want to wait. And what you really want to do is immediately figure out what is the SSID. So how do we do it? Well, very simple technique. What we actually do is think about a BSS where there is an access point which is non-broadcasting or has a hidden SSID, and there are clients already connected to that access point and are transferring data between the access point and the client. So what we are going to do is we are going to break that connection between all clients in the network and the access point. So what do you expect would happen next? The moment the connection is broken, the client will once again try to reconnect to the access point. When this happens, again the whole probe request, probe response, authentication request, authentication response, association request, association response packets will go through, and we will be able to look at the various fields in these packets and figure out the SSID. Right? Simple algorithm. Now the question arises, how will you be able to break the connection between all these clients and the access point? Now this is where, interestingly, if you remember the state machine, which we had learned right up in the beginning, we can quickly go to that specific slide. Here we are. If you remember, what we had said here was that if a client is in this state, which is authentication and associated state, then if we send a de-authentication notification, then it will go back to state 1, which is unauthenticated and unassociated, and once again the client will try to associate with the access point, right? So what we need to do is send a de-authentication notification to the client, or the clients in this case. How do we do that? Well, basically we have a particular management packet called the De-Authentication Packet. It is a subtype basically of a management packet, and when a client receives a de-authentication packet from an access point, it goes ahead and breaks the connection, right? And then retries once again, depending on the settings. So how do you generate a de-authentication packet is the next question. Now, in much later videos, I will talk about programming packet injectors and packet sniffers for wireless. For the time being, we'll use a nifty little tool called Air Replay NG, which is part of the Aircrack NG suite of tools. So let me actually go to my machine. And let me just quickly go back to the shell prompt, and let's start sniffing once again, right? And now let me open up a new terminal. Now, Aircrack suite of tools are the best tools out there for Wi-Fi hacking. I mean, I cannot stress that more. When I was giving a DEF CON talk way back in 2007, I had the pleasure and privilege to meet Thomas Diotrop, who is the main programmer of the Aircrack NG suite, and also Zero Chaos or Rick Farina, who's a good friend of mine. And it was an amazing experience to speak to both of them. So great work here. I mean, what do I say? I really appreciate what they've done by making this great tool. Okay, so we are going to be using Air Replay NG. Now, Air Replay NG is a Swiss knife. In the sense, it can do a lot of things. We'll take up many of its capabilities in later videos. The one we are interested in currently is to generate de-authentication packets. Now, there are two ways or two kinds of de-authentication packet. Now, imagine a BSS where you have one access point and 2 to 3 wireless clients connected to it. Now you have a choice of either breaking one connection between a client and the AP or breaking all connections in the network. And this is where when you break all connections, you call it a broadcast de-auth. And basically when you break just one connection, well, it is just a basic de-authentication packet targeting a client AP pair. Now, because we are impatient, what we will do is use a broadcast de-authentication packet, right? So the first thing which I'm actually going to do right now is let me quickly just set up the de-auth tool. So air replay ng, after that you have basically the -- de-auth option. 0 stands for broadcast de-auth, and after that we need to give the BSSID, but if you kind of forget the option, it will actually prompt you and say, well, use the -a option for the BSSID. A lot of times I forget many of these little parameters, so it does a good job at prompting you. Once you start this, it will actually send broadcast de-auth packets on behalf of the access point, and any client in the vicinity will break its connection and you will be able to see it reconnect back to the network. Now at this point, well, because I was using an iPhone, it currently turned its Wi-Fi off after I locked the phone. So what we'll do is let's just do the attack in 2 stages. One is, let me kind of stop the attack, stop the sniffing, and let me first connect my phone to the access point, SecurityTube, right? So now I am all up and running and connected. Oh, it's kind of connected to my home access point. Let me kind of make it connect to the SecurityTube network. And if you notice right now, it is connected to the SecurityTube network. I'll let the connection remain. And let me quickly start arrow dump ng. So if you notice, it says, well, a client is connected. Looks like I've been sending probe request responses. So a lot of times, here's the funny thing. The client, even if it is connected, may at times send probe requests for various networks. This it does to actually find the best available access point in the vicinity. So, we may end up getting a lot of those packets as well. Anyway, so what I'm going to be doing right now, okay, once again, it just got the packet. So let me just quickly go here and start the de-authentication exercise. So you would notice actually as soon as a de-auth is pumped that the little tick goes away. So right now, if you're noticing, there is a little tick. Let me kind of focus this properly so that you can see this on the screen. If you notice, you see a little tick there on SecurityTube. Now, if I start the de-auth attack, you will notice that that tick would go away, in the sense the client would be disconnected. Did you see that? And we are sending these broadcast packets. I'll stop the broadcast packet. It reconnects back. I start the broadcast packet once again. It disconnects. Stop it once again. It will immediately go back and reconnect, right? And in the meantime, arrow dump has been successful in actually going ahead and finding the ESSID of that network, right? So if you think of it more from a Wireshark perspective, and if we go ahead and start a trace file, and let's just now go ahead and send out the, okay, let me kind of switch on my little monitor once again. Okay, so here we are connected once again, and what I'm going to do is Wireshark sniffing is on. Let me start a little de-auth attack. Disconnected, and it's going to remain disconnected till the time I keep sending these broadcast de-auth packets. The moment I stop it, it would connect to SecurityTube back once again. Now let's analyze the Wireshark trace. Now, as they always say, packets can't lie. So anything and everything which is kind of happening here, you would be able to figure it out with these packets, right? So let me quickly look at all of these packets here. So this is just concentrating on the client, right? What we need to do is let's just clear the little expression here. and actually add two addresses. Let's also add the address of the access point. Right? So either one of these. Because the broadcast packet, broadcast de-auth is just sent to the broadcast address. So we would not be able to see it unless we put the OR clause. And what we really don't want is, well, we don't want to look at the beacon frames, right? So let's kind of put the AND not selected. And now let's actually go through the packets and actually start looking at what was being sent, right? So if you notice here, there are a lot of de-authentication packets which are being sent by the access point to the client. And this is what I was talking about, that de-auth packets are broadcast packets in this specific case where we are sending a broadcast de-auth. Now, moment these de-authentication packets kind of get over, we send tons of them. If you notice, the client has already started probing for various networks. So let's kind of scroll down fast here, see what's happening. So the de-auth packets are actually killing all possible connections, which is what we had seen previously. Tons of them. Error replay is a damn fast tool. You can configure the number of packets which need to be sent per second. The default one is pretty powerful to practically kill all connections, as you can just see by the sheer volume of the number of packets, right? Okay, let's kind of just going down and down and down. Couple of things with the live demo is, you can't always kind of ensure, well, it's a small little de-auth frame and then we actually see what's happening and all of that. So bear with me here. Even the suspense of what is lying below this de-auth frame is as much for me as for you, even because I did a live experiment right now, right? So, okay, let me kind of scroll through this a little bit more faster so that once we start seeing some data packets, we can actually figure out what's being happening. Okay, we kind of missed it somewhere here. Should be just above this. Awesome. So if you notice, there were a lot of de-authentication packets, and actually the probe request response packets are also there somewhere in the trace. Or we may have missed it while sniffing, but here is the thing. After that, you have the association request, association response, and then data starts flowing once again, and everything is normal, right? Awesome. And this is exactly how we can go ahead and actually pawn hidden SSIDs by using either a passive technique or an active technique, right? So hope all of this is very clear to you. Once again, I make these long videos just to ensure I explain every aspect of what we are doing. Hopefully you're still with me till the end and not getting bored in between. Please leave your comments behind. As I said, that's what charges me up, makes me actually feel that people are watching the videos, and makes me create many more, right? So that's all for this video. See you in the next one, and I'm just about to start creating the content for the next one, and basically it's called laughing off Mac filters. So as you probably already guessed, Mac filters are something which are also applied at times to go ahead and mitigate access or control access to a network, mitigate a hacker's access to a network. And what we will see in the next video is that it is absolutely useless and probably one of the most stupid things somebody could implement, at least on a wireless network, right? Okay, thank you, see you, bye-bye.